Okay, so now we will be solving for the activity given in class last time. So we are looking at the correlation between the math and English grades of 19 students. So we were asked to solve for the correlation coefficient and to predict the grade for math using the English grade, using, of course, linear regression. So first, we will solve for the correlation coefficient of these two variables. And again, correlation coefficient only measures the strength of linear relationship between two variables. And in this case, whichever is x and whichever is y variable, for correlation, it doesn't matter as of now in terms of arrangement. So we can choose math to be your x, or you can choose English to be your x variable. Okay, so any position will do. So solving for the correlation. So let's choose equals correl. There we go. Double click. Then choose the first group, whichever you want to choose. So I'll choose math as the first group, and then comma. And then the second group will be English. And then close the quantity, enter. So we have 0.53. Okay, so for uniformity, of course, we always round it off to two decimal places. Okay, so that 0.53 will be your R, or the correlation coefficient. And you can always check the scale that we have for the interpretation of how strong that 0.53 is in terms of relationship between math and English grades. All right. So now we move on to the linear regression equation. Okay, so for linear regression equation, it is now very important to identify which is your x variable and which is your y variable. Why is it important in linear regression? Because we are trying to predict one variable's value using the other variable. So in this case, we were asked to predict the math grades using the English grades. So therefore, the the variable being predicted will be your y variable, and the variable that we will use to predict will be the x variable. So because the y variable is the dependent variable, the x variable will be the independent variable. So that means the math grade will now depend its value on the English grade. So we can say that the English grade here will be our x variable, and math will be our y variable. Okay, so just to be safe, we move this here. Okay, oops, let's delete the first two. There you go. So English now will be our x variable, and math will be our y variable. Okay, so again, because we are trying to predict the y, or the math grades, using the English grades. Okay, so how do we get the linear regression equation? So we use a graph so that we can see the scatter plot diagram of the grades, or of the values of the data. So we go insert. So first, highlight the groups, highlight the data first. So insert, then scatter, then choose this first. Okay, so this is the graph. Okay, and then we go to format, layout. So we go to trend line, and then more trend line options. So we choose linear, since we are using linear regression, and then display equation and chart. This equation will be the linear regression equation. Okay, and again, for uniformity, we are, or we will round it off to two decimal places. So we have y equals, so 0.7581 will be rounded off to 0.76. Okay, x plus 19.998 will be rounded off to 20. Okay, so there you go. This is our linear regression equation. And since we are trying to predict the value or the grade in math using the grade in English, and we were asked to predict the math grade using an English grade of 98. So this x variable here will be replaced by 98, so that we can get the value of y, or the value of the math grade. So equals 0.76 times X here will be 98 because that's the grade for English that will be used to predict for the value of Y of our math. 98 plus 20. So remember that we are just using this linear regression equation, and there, 94.98. So if this is saying that if the English grade is 98, then the math grade will probably be 94.48. All right, so that is the use of linear regression equation. Okay, thank you.